So in this example here, we actually go away from numbers and start dealing with variables. And you're being asked to simplify each of these expressions. So to do that, we actually need to take into account the definition of what a factorial is. So in A, we have n plus 3 times n plus 2 factorial. Well, n plus 3 doesn't have a factorial, so we can just take it. But n plus 2 factorial does. So it would help in this case to write out the actual definition of what n plus 2 factorial is. Now, that's a little bit more difficult than just 5 factorial because we can count down from 5 to 1. With n plus 2, we don't know what n is. But we can use a little bit of logic, a little bit of thinking, and simplify this out. So a factorial is that number multiplied by the number 1 less than it, and then multiplied by 1 less than that, and so on until we get down to 1. So to start off the definition of n plus 2 factorial, we would have n plus 2. That would get multiplied by a number that is 1 less than that, which we could call n plus 1. Which would then be multiplied by a number 1 less than that, which would just be n. Multiplied by a number 1 less than that, which would be n minus 1 now. And we could keep this going, but we don't know how long it's going to go, so we'll skip until the end, and we know that the end of every factorial will multiply down until eventually we'll multiply times 2 times 1. Now looking at this, this would be exactly the same as if we had written out the definition of n plus 3 factorial. So that would be how this is simplified. I'm just going to clear off the page to do example B because it is going to take a little bit more space. B, we have a fraction, but we have 2 factorials. We can write out the definition for each one. N plus 1 factorial would start it off as n plus 1, multiplied by a number 1 less than that, which would be n. 1 less than that would be n minus 1. 1 less than that would be n minus 2. 1 less than that would be n minus 3, and so on, and we know we'll end times 2 times 1. Now, the amount of terms that you write out is up to you. I limited myself based on the space I had. On the bottom, we have n minus 1 factorial, so writing out the definition of that, we would have n minus 1. 1 less than that would be n minus 2 times n minus 3, and we can see the pattern, times n minus 4 times n minus 5 times n minus 6, until at the end we multiply times 2 times 1. Now the nice thing with the division with factorials, we look for things to cancel. We have terms of n minus 1, factors of n minus 1 here, factors of n minus 2, n minus 3. Now the confusing thing happens with this n minus 4 on the bottom. There is no n minus 4 written on the top, but it is there. I chose not to write it just because of my space limitations, but if I had written it, it would be obvious. It is still there. Everything else inside this omitted part will also cancel because we'll have n minus 5s, n minus 6s, and so on and so on. The 2's will cancel, the 1's will cancel, and so we are left with n plus 1 times n. Now we could choose to distribute in that n. We don't need to, but if you choose to, you distribute the n into here, and we would end up with n squared plus n. Either answer is okay. Just depends on whether or not you feel like distributing that n in or not.